Okay, welcome back. This is a continuation video from the previous one where we talked a little bit on domain and range and what that means and parent functions. If you haven't seen it, please go back, check it out, and then circle back to this video if you're weak on that topic. So in this video, we're going to touch a little bit on domain and range and looking a little bit deeper into the parent functions and how to identify the domain and range for each parent functions. I'll probably do 4 examples, and hopefully you get the general gist of how to identify graphically how to find the domain and range of a few of these parent functions. So for the first function that we have here below, this is a linear graph or linear function. It's identified by a diagonal line that cuts directly through the origin of your graph, and it runs from the bottom left quadrant to the top right quadrant, right? As you can see here. So as I said before, the domain refers to the input values or your X values. So an easy visual way to identify that, if I were you, is I would come along here and you see all your all the values on your x-axis, right? This horizontal line. If you can do a vertical dotted line or any vertical line connecting a number from your x-axis to the function, which is this blue diagonal line, then that number is an input on your function. Meaning the number 1, 2, 3, 4, 5, all these numbers are possible inputs of your function. Likewise, so that would be your domain, right? So these are potential inputs. Likewise, I could use red here or green. The same goes for the outputs. So if I do horizontal lines, these are supposed to connect. Bad graph, but these are supposed to connect like that. There, one. This one goes this way. -2 comes this way, this way, this way, right? So you can see I've made some horizontal lines. These are straight lines, just bear with me here. So these are supposed to be straight horizontal lines that touch your function. So wherever these green dotted lines touch your function, those are showing you what your possible outputs are for your function. So in this situation, your domain, you could say the number 1 is a part of your domain because I can draw a dotted line from 1 to the function. The same with 2, 3, 4, 5. And on the negative side, you can see that these numbers are a part of your domain. Horizontally, for your range, you can see the same thing. So it's almost like you're trying to cut the graph with horizontal lines, and if it touches, it shows that that number is a part of your function's range. So -1, -2, -3 lines up perfectly with your graph and connects. So in this situation, notice that there are arrows at the end of the linear line I drew, or this diagonal line. That is indicative or implies that the line continues forever. So I could keep, theoretically, this line is going on and on and on and on all the way to infinity. Same in the opposite direction. This line is going on and on and on towards negative infinity. So horizontally, if you think infinitely, you can see that your domain is going from negative infinity to positive infinity, right? And then for the y, or your range, it's the same concept. These lines are infinitely going down and infinitely going up. and it keeps going and going and going. So your range is going from negative infinity. You always start with the smaller number. So from negative infinity up to positive infinity. So my range would be negative infinity to positive infinity. And there's a cool thing in math that says if my domain and range are going from, let's say, negative infinity to positive infinity, you can rewrite that as all real numbers, because it means every number is included in this domain and range. So I could write it like this: all real numbers, which in math they write like this: a line and then an R. So if you see this, it means all real numbers. So that's what you're looking for a domain and range. So I spent a little bit of time on this one. I won't spend as much on the others because I just want you to visually see what's going on. So let's look at the parabola. So this is an open-faced parabola, or a quadratic function. Quadratic function. So in this situation, our domain and range, well, what did we talk about last time? If I'm looking for a domain, I'm looking for x values. So I'm going to find all my x values on my function, right? So I'm essentially drawing vertical lines up and seeing where they touch on my graph. And notice that this parabola is open-faced, like a smiley face, and the arrows also imply it's going infinitely to the left, infinitely to the right, which means my domain in this situation is also going to be negative infinity to positive infinity. Because at no point will I continue going towards negative infinity that a green dotted vertical line will not touch the graph, because it's going infinitely this way and also infinitely that way. The range, however, is a little bit different in this situation. Remember what I said, you're drawing horizontal lines from bottom to top, and wherever it touches the graph is a part of your range. These are the y values, right? So if I were to draw horizontal lines, well, let me make it dotted for consistency. Notice that all of these dotted lines that I'm drawing here, they're not touching this parabola, which means no number that's negative is a part of this range, because these dotted lines are not interacting with my function. But the minute I get to y is equal to 0, which would be at the origin, let's say this is 1, 2, 3, and so on, then now we have some form of interaction. So our range starts at this point right here. This is the lowest part of our function. So the range starts at 0, and it goes infinitely up. 1, 2, 3. Just keeps going and on and on and on, because these arrows go infinitely up towards infinity. So my range goes to infinity. You probably are wondering, why is it that I have a parentheses on some of these numbers here for the domain and ranges, and a square bracket for others? So a quick note on that is, a parentheses implies that you are not including the number at the end. So you're close to that number, but you're not including it, which makes sense. Infinity is not a physical number. It's more of, it's an increasing value in this situation, whether positive or negative. So it never ends. And so you can't put a square bracket on something that never ends, because a square bracket implies that you have a physical point. So you use, for infinity, always use a parentheses. But in this situation, there is a physical stop at the lowest value, right? Which it's 0 for the range. That's why that has a square bracket. So a square bracket implies that you have a solid point and it's not, it is included, whereas a parentheses means it is not included. Okay, so hopefully you understood what I did there. So the lines go all the way across. In this situation, I just showed it going to the function, but it goes all the way across, and wherever it touches implies that that's a part of your range or your domain. Okay, so hopefully so far you guys are understanding that. Let's look at this example. Third example is the graph of y is equal to the square root of x. So this is a square root function. Let's go a little bit faster with this one. Well, immediately I see that the function starts at the origin, which is 0, right? So my domain, which are my x values, I wouldn't include anything that's negative because none of these vertical lines are touching my function, but at 0, they start. Therefore, and it's a solid point. So therefore, my domain starts at 0 and then goes towards infinity, because that arrow implies infinite numbers. Square bracket on a 0, a parentheses to close off the infinity. What about the y values? Well, same thing. There's no y values at the bottom that are interacting with my function, but at 0, it starts, right? So we know the y values start at 0. And then this graph tapers off in a increasing manner in the quadrant, in the first quadrant, the top right quadrant, which means that these lines will forever go to infinity. It's increasing. It's not plateauing. It continues to increase. So we can confidently say that our range is also 0 to infinity. Okay, and I think I had one more example here. So this is the reciprocal function. So in this situation, we'll talk about this more in a later session, but this graph has something unique, which are called vertical and horizontal asymptotes. And an asymptote is essentially treated like a void, or like some form of untouchable gap that you can never cross. And it runs like this visually. There's one that's going down like this, and then there's another that's going across like this. The arrow, these functions can approach the red and green lines, but they can never touch them. I know it's kind of weird to imagine, but it's almost like they're curving and then they get as close as they can get, but they never touch these lines. So imagine I had this as 1, 2, but let's go in this direction. Let's say this was, 0.5, and then this was 0.000005. It gets smaller and smaller, but these values will never actually get to 0. Likewise, for the horizontal axis, if this were -1, -2, imagine that this is as close to 0 as you can get from a negative perspective, some long 0, but you never actually get to 0 because these asymptotes, horizontal and vertical, prevents you from touching that part of the function. This is just the nature of what the function looks like. So it's just something to be aware of. Vertical asymptote, right? Okay, so in this situation, the domain would be, you're doing your same vertical lines as well, right? It's still going to be negative infinity, because you can see you can have you can draw vertical lines. As this arrow approaches infinity, you'll always touch a part of the function, right? But at 0, there's a cutoff because I drew this vertical asymptote here. So what you would write is it goes from negative infinity to 0, where it doesn't touch 0, so it's a parabola. And then there's a union sign, means like an and. It starts back at 0 again. Remember, this means I don't touch it. I get as close to 0, but I never touch it. It's not included. And then I go all the way towards infinity on the right-hand side, right? These lines right here. It might be a little bit confusing. That's understandable. It's a new concept if you haven't learned it before, but that's the general gist. Likewise, for the range, it's a similar concept. You can see the lines going down, right? This one goes down infinitely, this one goes up infinitely, but they never approach, they approach, but they never touch 0. So it's the same concept, negative infinity to 0, union 0 to infinity, or all real numbers except 0, all real numbers except 0 for the range. So that's the idea, with a few examples of domain and ranges for parent functions. Hopefully the variety of the questions that we went over gives you a better foundation when you're looking at domain and ranges for parent functions or functions in general. It's all about kind of seeing those dotted lines, drawing your invisible vertical and horizontal lines in your mind and seeing where they touch to get like an idea of if this is an input or is this a potential output or not. Okay? All right. Well, let me know if you have any questions in the comments. Drop it. If I made a mistake, you can let me know. I'll pivot for subsequent videos to follow. All right? Thanks. Bye.